Alright guys, this is Mr. Lynch. As always, make sure that you guys are liking the videos and subscribing to the channel to make sure that you guys see all the videos as they come out. Make sure you guys hit that notification bell. Alright, so here we go. Geometry, lesson 3, the scaling principle of area. This is a really important thing when it comes to scaling these figures. You guys remember when we did dilations and we were scaling these up and down? Well, now we're going to look at what happens to the area. Alright, so A. Right here, area of original figure. What we're going to do is area is equal to base times height divided by 2, which gets us 3 times 8 divided by 2. And I'm going to turn my ink to shape. 8 divided by 2 gets us 4, so we have 3 times 4, which equals 12. So we have an original area of 12. Now we're going to scale this up by a factor of 3. So we're going to take everything and multiply it by 3. So this base down here becomes 24. This height becomes 9. Now, the area, we're going to follow the same formula. 9 times, I don't know what happened there with that 9. 9 times 24 divided by 2. 24 divided by 2 is 12, so we get 9 times 12, which is equal to 108. Now, you guys can see right there, something's happening. The area of the similar figure is 108. Now look at this real quick, guys. Our original area was 12, and we can see down here we end up with 9 times 12. So our area is 9 to 1. Weird how stuff like that happens. So let's look down here at B. What's the area of this? Well, again, base times height divided by 2. 3 times 5 divided by 2. We're going to get 15 divided by 2, which equals 7.5. So we're going to come back up here. Area of original figure, 7.5. Now our scale factor is 2. So we're going to come back down here, and we're going to redraw this triangle. So this becomes 6, and this becomes 10. So, again, plug in our formula. 6 times 10 divided by 2 is equal to 6 times 5, which is 30. Now, how do we get from 7.5 all the way up to 30? Oh, oops, not dimensions. 30 is the area. Well, how many? That's kind of out of the question. Anyways, it's going to be a 6 to 1, right? No, it's going to be 4 to 1. Sorry, guys. 4 to 1. 7.5 times 4 gets us 30. Now let's look down here at C. Our area here is just base times height, so we're going to get 20. And let's find the area of D, 6. So CD, we're going to come back up here. C was 20 and D was 6. Now, C, our scale factor is 1/2. So we're going to come back down here. We're going to redraw this with a scale factor of 1/2. So this right here becomes 2. This becomes 2.5. Multiply these together. 2 times 2.5 gets us 5. So our area of the similar to the area of the original is 1 to 4. Now let's look at D. We're multiplying it by 3/2, which means it's going to get bigger. So let's draw our new, parallelogram. If we multiply this by 3/2, we get 3 there, and we get 9/2 down here. Multiply these together, we get 27/2, which is 13.5. So 13.5. Now, our area of the similar to the area of the original is going to be what? What is 13.5 divided by 6? I'm going to pull up my handy-dandy calculator right here. So 13.5 divided by 6 gets us 2.25. So it is a 2.25 is 9/4. So it's a 9:4 ratio. Okay, so what you guys should be seeing right here is that this ratio, we can write this as a fraction too. So 9/1, 4/1, 1/4, 9/4. What you guys should be seeing right here is that all we're doing is we're taking the scale factor and squaring it to get the ratio of these areas. This is equal to 3 squared. This is equal to 2 squared. That's 1/2 squared. And that's 3/2 squared. So as you guys can see here, our scale factor, so if we take down the side lengths by this scale factor, when we multiply it together, that's going to be a squared effect. All right, so let's look at E. And like I've just said, we're squaring the scale factor to get new area. So scaling principle for triangles. What this means is that the area of the original compared to the area of the similar figure, as you guys saw up here, it is the scale factor squared. Now, why do you guys think that is? Well, if we take the original, so we know our area is base times height divided by 2. That's our original figure there, is base times height divided by 2. Now, in our area of our similar triangle, we have some scale factor. We'll call it S. So it's S times our base times our scale factor times our height divided by 2, which gets us our base times height divided by 2 times our scale factor squared. And this is going to be the same thing for polygons, as you guys can see, as you guys saw above. So if we're looking at, a parallelogram, our area is base times height. And if we look at the area of the similar figure, we're going to get our scale factor times base times our scale factor times our height, which gets us our scale factor squared times base times height, which gets us our scale factor squared times the original area. So rectangles A and B are similar and are drawn to scale. If the area of rectangle A is 88 millimeters squared, so this is 88 millimeters squared, what is the area of rectangle B? Well, in order to find that, we need to find our scale factor. So how do we get from A to B? 30 divided by 16 will get us that answer, which is 15/8. Now, we're going to take this and we're going to square it and multiply it by that 88 to get the area of B. Is equal to our scale factor squared times the area of A. So the area of B is equal to 15/8 squared times 88 millimeters squared. And now 15/8 squared, let me pull out my handy dandy calculator again. So 15 divided by 8, and then you square that, gets you 3 points. So the area of B is equal to 3.515625 times 88. So the area of B is equal to 309.375 millimeters squared. Hopefully that makes sense to you guys. If not, please go back and watch the first part of this as we work through that and we show that that has to be true. And if you guys need to, as always, take a break whenever you guys need to. Pause the video, go get something to drink, go get something to eat. Do something in between these videos because I know these videos take a while. All right, so now number 2. Figures E and F are similar and are drawn to scale. If the area of figure E is 120 millimeters squared, what is the area of figure F? Now, as you guys can see here, this is going to be a little bit tougher of one because we have to figure out what the scale factor is. So 2.4 centimeters. So 2.4 centimeters is 24 millimeters. And this is why the metric system is so much better. 24 millimeters. Okay, so now how do we get from E to F? Well, we're taking 15 and dividing by 24. That's our scale factor. Now, 15/24, we can reduce that to 5/8. So now what we're going to do, since we know that the area of F is going to be equal to our scale factor squared times the area of E, the area of F is going to equal 5/8 squared times 120 millimeters squared. 5/8 squared is 25/64, but I don't know what that is as a decimal off the top of my head, and neither should you. 5 divided, not percent, 5 divided by 8 squared times 120 gets us an area of shape F equaling 46.875 millimeters squared. So all we're doing, guys, all we ever have to do is just follow this little formula right here. All right, the area of this shape is going to be equal to the area of this shape multiplied by our scale factor squared. And I showed you guys that that works in the previous one. So here's our summary, the scaling principle for triangles. If similar triangles S and T are related by a scale factor R, then the respective areas are related by the factor of R squared. If similar polygons P and Q are related by a scale factor of R, then the respective areas are related by a factor of R squared. If similar triangles A and B are related by a scale factor of R, then the respective areas are related by a factor of R squared. So all that's saying, guys, is that in order to find, so let's look up here at triangles. The area of S is equal to the area of T times R squared. The area of P is equal to the area of Q times R squared. And the area of A is equal to the area of B times R squared. So as we scale up our sides, our area is scaling up by that same thing squared. So here's our problem set for you guys. A rectangle has an area of 18. Fill in the table below by answering the questions that follow. So here, our original dimensions are 18 by 1. Our new scale dimensions are 9 by 1/2. So our scaled area divided by our original area gets us 9/2 divided by 18, which is, what's our scale factor here, guys? Scale factor is 1/2, which means that our area ratio is going to be 1/4. So if we take our scaled area and divide by our original area, we're just going to say that it's 4.5 divided by 18, which will get us that 1/4. So list 5 unique sets of dimensions of your choice. Typo. For a rectangle with an area of 18 and enter them in column 1. So all it's asking you to do is just find 18 unique dimensions. So we could have a, 9 by 2, but it has to equal 18. We can have an 8 by nothing. I don't want to do an 8 by, I don't want to do a decimal. 6 by 3. And just follow this pattern. And then look at these scaled dimensions. If the given rectangle is dilated from a vertex with a scale factor of 1/2, what are the dimensions? So what you guys are going to do is our scale factor is always going to be 1/2, is what it's saying. Now, you guys are going to have to figure out working through this, all right? I believe in you guys. Follow these instructions. They're actually really clear, which is nice. So, find the ratio of the areas of each pair of similar figures. So the ratio of the areas, we're just going to take our scale factor. So if we're going from small, let's just say we're going to go from left to right. So then we need to multiply. Our scale factor r is equal to, in this case, 5 divided by 2, which equals 2.5. So then our ratio of the areas, I'm going to call it r sub a, is going to equal that squared. So it's 25/4. Over here, scale factor, our ratio r is 2/3, from moving from left to right, which means that our ratio of the areas is 4/9. I'm going to let you guys do C. Just follow this pattern, guys. Remember, make sure you're going left to right. In ABC, line segment DE connects two sides of the triangle and is parallel to line segment BC. So DE is parallel to BC. If the area of ABC is 54 and BC is 3 times DE, find the area of ADE. Well, that means that if we're going from ABC down to ADE, so DE is 1/3. So DE, not square E, DE. Oh, I hate this ink to shape sometimes. DE is equal to 1/3 of BC. So that's our scale factor. Our scale factor is 1/3 for those sides, which means that our area, our ratio for the area, is going to be equal to 1/3 squared, which is 1/9. So then, as we know, the area of ADE is going to be equal to our ratio of our area times the area of ABC. And now we know what both of those are. So we know that this is going to be 1/9 times 54, which gets us 6. Because 54 divided by 9 gets us 6. The small star has an area of 5, and the large star is obtained from the small star by stretching it by a scale factor of 2 horizontally, and by a factor of 3 in the vertical direction. Find the area of the large star. So, what we're doing here is you guys need to find this area. All right? So, sorry about that, guys. So, if we're going up by a factor of 2 in the horizontal direction and by a factor of 3 in the vertical direction, and our small star has an area of 5. Well, if we were to just make it bigger by a factor of 2, that wouldn't work. That would only get us part of this. You guys, I'm going to leave that one to you guys. I will be covering this in my video on Thursday for you guys just to make sure you get it. A piece of carpet has an area of 50 yards. How many square inches will this be on a scale drawing that has 1 inch represent 1 yard? So, a piece of carpet has an area of 50 square yards. How many square inches will be in this scale drawing that has 1 inch represent 1 yard? 50. Because all we're doing is saying that 1 inch represents 1 yard. So how many square inches will be on this scale drawing? 50. And I'm going to call that it for the video. If you guys have any more questions, please just email me. You guys can call my phone at the school, and it will ring on my phone here at home. As always, I hope you guys enjoyed the video, and I hope it really helped you guys understand this lesson a little bit better. As always, like and subscribe, and make sure you guys turn on that notification bell so you guys can see as soon as videos come out.